well for anyone who wants to review it later. Okie dokie. Get the captions up here. And the one more thing I want to do is get out the chat in case any of y'all who are remote want to say anything. So we will be able to see what you're saying. Make it out of the way a little bit there. Alrighty, so I skipped this video the other day, but I think it's fun, so I'll start with this today. This is a video of 3 discoveries that happened, or at least were published during the past year. So I thought that this was really great to show that, like, science doesn't stop, right? And there were certainly challenges. If you worked in a lab, a lot of times you couldn't access your lab. Sometimes money was frozen because no one was at NIH to administer it, for example. But, science trucks on and people kept doing things. So.
It's probably fair to say that just about everyone's brains this year have been dominated by this pandemic. But other science stories did happen in 2020, including amazing discoveries about everything from dinosaurs to parasites. We didn't get a chance to cover all of them, but now they're getting their chance to shine. So here are 3 unbelievably cool stories you might have missed. First, back in April, researchers settled a major argument about dinosaurs. For a while, scientists had figured that pretty much all species of non-avian dinosaur were terrestrial. They could venture out into water every now and again, but they mainly stuck to dry land. The major exception to this, however, is Spinosaurus Egypticus, often known as Spinosaurus for short. Based on features like its long, narrow jaws and croc-like teeth, we've thought it was at least semi-aquatic, maybe hunting along the rivers in northern Africa, although that idea was definitely met with some pushback. Now, though, there seems to be strong evidence that it wasn't just prowling around rivers, it may have been a proper aquatic beast. The key evidence was published on April 29th, and it comes from tail bones discovered in Morocco in 2018. We don't have a ton of fossils of Spinosaurus because they were accidentally destroyed in World War II, so this was a major find. Researchers used the fossils to make a digital reconstruction of the whole animal, and they found that its tail would have looked a bit like a newt or crocodile's tail. Long, flat, upright, and strong. What's more, scientists also made and tested a robotic model of this tail and found it could probably produce enough force to let the animal swim. If this is confirmed, it would end a years-long argument and really expand our picture of where dinosaurs lived and what they were capable of. Next is a story about other swimming giants, also from April, and it involves a clever solution to a tricky puzzle. In the spring, scientists figured out that we can use nuclear residue from Cold War tests to figure out how old whale sharks are. Whale sharks are the largest living species of shark, and we want to understand and protect them. But that's easier said than done. Like, one thing we'd love to know is their life history, things like how long they live and how fast they grow. But there was a conundrum. Researchers couldn't agree how to measure their age. There are growth bands on their vertebrae, like tree rings, but studies were conflicted about if one ring equals 1 year or just 6 months. Well, it turns out the secret to figuring it out was nuclear weapons tests back in the 1950s and 60s. Scientists realized those tests would have increased global atmospheric levels of a rare form or isotope of carbon, called carbon-14, and it would have been picked up and incorporated into the shark's bones. So the scientists got vertebrae from 2 of the oldest deceased specimens available and compared the isotope levels in their vertebra's bands to ocean water samples from years ago. By looking at the bands and the amount of carbon-14 in each, they were able to figure out what year different bands were put down. And with those landmarks in place, they finally put the original question to rest and concluded that each band equals 1 year. Using this new knowledge, the scientists were also able to conclude that whale sharks grow more slowly and live longer than we'd generally assumed, something that could help us better understand these ocean giants and how their populations are doing. Finally, in May, news broke about one of our most notorious diseases, one that's been plaguing us long before COVID-19. Malaria. One of the signature signs of malaria is regular recurring fevers. These happen because the malaria parasites enter and breed inside red blood cells, then burst out in a synchronized wave of new parasites and waste materials. For the parasites, it's possibly a way to evade the immune system. But for humans, All those waste materials trigger a fever. But what's interesting is that depending on the exact species of parasite, these waves can happen like clockwork. Like some species that infect humans trigger fevers every 2 days, others every 3. For a long time, we've thought that the parasites may be using the host's circadian rhythm to time things, basically our daily internal clocks. But in May, we got published evidence that the parasites use their own biological clock instead. To figure this out, scientists bred mice to have different circadian rhythms, some normal, some longer, and some non-existent. Then they infected the mice with the parasites, and they found the parasite cycle would kind of adjust to match their host, but not perfectly. Also, the parasite cycle existed even in mice without consistent circadian clocks. This all suggests that the parasites have their own clock, though it's kept in sync by cues from the host's body. That helps the individual parasites sync up with each other. The scientists even identified genes that might be behind this. Now, there isn't a huge conclusion about how to treat malaria here, at least not yet, but it's completely possible that this hidden interaction is something we could tweak and exploit to our benefit to put another deadly disease to rest. So 2020 has been quite a year, but in the science world, there's a lot to celebrate. Some scientists have been tackling this pandemic, including studying the virus and potential treatments and vaccines. Meanwhile, researchers like these have been pouring time and energy into conservation, natural history, and other diseases. And in both cases, our understanding of the world is that much better for it. Thanks for watching this episode of Science.
Alrighty. So a couple things I want to point out for that. One is that this stuff's still getting published, which is really cool. A second one, which I don't know if people picked up on, is the first study they said was from some bones they discovered in 2018, and then it got published in 2020. That's not unheard of, and in fact might even be a little short for journal publishing cycles. So I know one of the things you read for Wednesday was about like how to read a journal article, but just like some background on how journal articles work. So you collect your data, right? And that might take you any amount of time depending on the size of your participant pool, right? So, if you're at a large university, when I collected my master's thesis data, I got data from 250 people in about 2 months, and they came in person. Okay, so pretty easy to get people there. Flip that, when I was on my sabbatical 2 years ago here, I tried to collect some data on guys, and only got 13 after a whole semester of like really trying hard to get people, partially because of our small sample size, and also because I realized I made the design too complicated. So you learn things like that. It's not uncommon to take a while to collect data. And I mean, in the case of something like dinosaur bones, they have to find them, right? So that might take a while. Then you have to analyze your data, write up the manuscript, and then submit it for publication. So typically when you submit it for publication, it's sent to 2 to 3 peer reviewers. These are people who should be experts in your subfield. Sometimes this is hard. So I was telling my WGS class, I think yesterday or the day before, that for example, I write in a subfield where I look at feminist beliefs as a protective factor against disordered eating and body dissatisfaction. So you can get people who are experts in body image or disordered eating, right, who have never looked at the feminism data. And so one of my colleagues, there's a pretty small network of us that do this research, got feedback from her peer reviewers that she, I don't understand why you had a typo in this. And she was citing, I saw a little tiny stub of chalk the other day. She was citing the feminist author Bell Hooks, whose name is published this way, just like E.E. Cummings, all lowercase. And they were like, why isn't Hooks capitalized? So like even people who are experts in one part of the field may know nothing about other subparts of the field. And that's before you really get into things like, people who study whale sharks might not study whale shark vertebrae, for example, right? So finding those experts can be a challenge. Usually, depending on the quality of the journal, it could take 2 to 3 months to get those reviews back. And then you get either just rejection, oh, sorry. You get what's called a revise and resubmit, where they say, the peer reviewers have given you helpful comments, please make them, and then we'll re-review it. or very rarely, they might just accept it. I have heard of people this happen to, just no one in my like close circle, let's put it that way. Maybe eating disorder researchers are like super critical when we review papers, I'm not sure. So, but if you're submitting to a higher caliber journal, so I have one publication so far, hoping to submit another one within the next year in the Journal of Abnormal Psychology, which is pretty overarching journal, really big impact factor, which means a lot of people can have access to that information. It took, I believe, 8 months to get my first set of reviews back. So, you know, it can take a while, and it depends on the subfield. I had someone in another subfield tell me she's never waited less than a year to hear back. Part of it is honestly getting reviewers. So I am in a position right now where I'm actually serving as a guest editor for a special issue for one of my favorite journals, Body Image. And just finding people to review is really hard. And I think I've mentioned this to y'all before. You don't get paid to review. So like you have to have someone who is like service-minded, who doesn't have a whole bunch of other stuff going on right then. Like I usually try to just accept every review that I can. But during the pandemic, I turned some down because I was like, I'm just trying to like stay afloat, provide childcare to my daughter, right? Things along those lines. So it can be a challenge. I mean, there were some papers, again, I'm just trying to get like 2 to 3 reviewers. There were some papers, I think I went through like 10 people to find that. And every time you have to give that person a week or 2 to respond to the invitation to review. So that can just drag on and on and on. So a little bit of fun fact about the process of science. And this is one of the reasons why the vaccine development is so great, because it shows that when we throw a lot of money at an issue, right? And granted, the mRNA vaccines had been in development since the early 2000s, right? But when you throw a lot of money at something, you can do the science quickly, right? So they did those trials really quickly. They did everything they normally do over a longer period of time, just they had the money and the resources to do it all at once, right? So definitely nice advances in science, and it ticks on, essentially. Alrighty, let me pop the chat back up because I minimized it here, just in case. Okay. All right, so what's a fact? How do we decide what makes it the fact level? Yeah,
It's something that I don't know
yeah, and usually experts, right? Things that have built up research over time. Yeah. And so a fact, this is defined by your book, is information presenting as having objective reality. It's often considered truth, but it could change with scientific discoveries, right? So again, when I was growing up, I learned there were 9 planets. That was one of the facts I learned, right? And then all of a sudden, poor Pluto, not a planet anymore, right? We talked about the other day, like Pluto was always a planet in our hearts. So things that seem like they're sort of concrete can change with new discoveries or new perspectives in science. So when we look at facts, we want to look at the validity of them. So is it credible? So when we say we want to look at the validity of a fact, we're saying, is it credible? Like, is there stuff to back it up? Is it coming from a reputable source? Right, things along those lines. Now, in psychology, we also use the word validity in a different way, and that is the validity of a measure. And so this would be like a questionnaire or an intelligence test or some sort of behavioral observation system. When we look at that, we're saying, does this actually measure what it says it does? Okay, so these are sort of 2 different meanings, obviously related, but of the same construct. Or the same word within psychology. All right, So what do we think of what these different facts mean? So what does it mean that the Earth orbits around the sun? And like, how did this fact change people's perspectives? We can go with that. We'll go Aaron and Debbie.
It means that the universe isn't like centered around the Earth.
Yeah, we used to believe that we were literally the center of everything, right? I mean, A, because that's all we knew, right? And B, because in some ways humans are a little narcissistic as a species, right? Yeah, Debbie. Okay, yep. Yeah, exactly. So, you know, objectively, scientifically, it means that, you know, we go around the sun, not the other way around, right? The repercussions of that fact were huge, right? So people like Galileo, who were making discoveries related to this, were tried as heretics. One of my favorite quotes is by Galileo, and he says, "I do not believe the same God who has endowed me with reason would expect me to forego its use." It's a little bit of a paraphrase, but you know, he really believed that this was correct and stood by his guns, and you know, yes, he was correct. All right, here's one everybody still remembers from high school science, right? The mitochondria are the powerhouse of the cell. What does that mean? Yeah. Exactly, yeah, and then like eventually we got to like the atom level, and then we realized, oh, but the atoms are made up of things too, right? Yeah, so that the cell has its own energy source, sort of, right? That synthesizes energy. It's like its own little battery, I guess is the best analogy. Yeah, and that it's not just the smallest element. Exactly. What does it mean that water is H2O? Just like factually. Yeah. Yeah, so 2 hydrogen, 1 oxygen, right? But that also meant a lot of other things, right? Again, kind of similar to the cell, figuring out that like this is not just some amorphous thing that exists, it's made up of other things, right? One of my favorite, I think it's sort of defunct now, one of my favorite Facebook pages for a while was called Dihydrogen Monoxide Awareness. And it was sort of making fun of all the people who are like, you can't have things with chemicals in them. Because like everything's made of chemicals, right? Like water is a chemical. So it'd be like, did you know the human body literally cannot survive without the fact we're so dependent on it? Do you know that hydrogen monoxide is in Clorox? Why would you put it in your body? Right, things along those lines. How about this one? This is one you may have heard in intro. That the span of a human's short-term or working memory is 7 plus or minus 2 items. Or, as I found when I was Googling this yesterday, or Tuesday, I think, when I was making this, some science now suggests it's 3 to 5 items. What does that mean? And this one's a little trickier if you haven't taken higher level psych classes, but essentially it means if I were to give you a list of discrete pieces of information to remember, whether they're like numbers, words, things along those lines, you are likely to remember essentially between 5 and 9 of them, and that would be sort of the max of how many you could remember. Again, with this study, I looked at, it actually is saying that it might have always been an overestimate, there we go. And that it might actually just be 3 to 5 items. And that in fact, when you get to those higher levels, like 9, people might be doing what's called chunking, which is where you start to put things into groups and remember them that way. So like phone numbers, for example, we've always known people chunk when they remember those. Like, yeah, they might be, what is it, like 10 digits, but we're remembering like the 757 and then the first 3 and then the last. So we're really only remembering 3 items. And then there are genetic aspects to mental disorders, such as anorexia nervosa or depression. What does that mean? Yeah.
That's a big thing. people are like, well, you're just crazy, or
Right.
you just need to sleep, or you just need to be happy. Like, it's not that simple.
Right, exactly. And the other part of this is that for years, especially anorexia, we were just like, well, it's just because your mom was over controlling. Like, it was the legacy of Freud, you like to blame everything on mom, right? Well, no, this is saying like there's actually something biological in your genes that's linked to this. So Cindy Bullock out of UNC, so our neighbor 3 hours away, has been doing, she started, I think, with 5,000 people, and now she's up to like 20,000 people, a genetic study to look at people who have and have not been diagnosed with anorexia. I'm actually in the study as a control because I was like, hey, I'll help contribute to science. And has really been showing, yes, there are specific genetic markers linked to anorexia, and that's a huge deal. So here is that article I did find the other day. So this is again a 2000 article. So this was out when I was in undergrad, but I learned the 7 plus or minus 2, right? So really interesting, that they reconsidered mental storage capacity. And so this is something, again, that's still sort of taught as fact, but has some debate about it by the scientists who study memory. Again, that surprised me. If anyone does want to actually read the article, I have a link to it here. A central memory store limited to 3 to 5 meaningful items in young adults. So they've looked at it in probably college students. All right, another big thing that a couple of you have already brought up on perusal, right? It's like, oh, this is why you all always tell us correlation does not equal causation over and over and over, right? We'll talk about this more when we talk about data later in the semester, but this is kind of a fun video about why we're so careful about them.
As explained in another video, we calculate the correlation coefficient for 2 variables to determine not only if the 2 variables move in the same direction, but also how strong the relationship is. However, as a famous phrase tells us, correlation does not imply causation. In other words, 2 variables might indeed move in the same direction and the relationship may be quite strong, but this doesn't mean we can draw a, let's say, cause and effect conclusion, with changes with respect to one variable causing changes for the other. In other words, the correlation coefficient can tell us that 2 variables clearly move in the same direction, but it doesn't tell us why. A pretty popular example is represented by ice cream sales being correlated with homicides in New York. Yes, statisticians may very well have noticed that when ice cream sales go up, homicides do the same, and when ice cream sales go down, homicides go down. But that doesn't mean ice cream makes people kill one another. In quite a few cases, we're simply talking about coincidences, even if the correlation coefficient is robust. Or, of course, there can be hidden factors at play. In our situation, we can take a step back and notice that the weather is the hidden factor which affects both ice cream sales and homicides. Simply put, more people buy ice cream when it's sunny outside on the one hand, and more people go out when it's sunny on the other and end up representing potential homicide victims. To put it differently, ice cream sales and homicides may be correlated, but there is no causal relationship there, whereas there is a causal relationship between the weather and ice cream sales, as well as between the weather and homicides. Pretty logical, right?
So, and there's whole websites of these, actually, of these sort of like spurious correlations. So if you sort of Google like spurious or weird correlations, you'll find like tables that do things like this. One of my favorite was like Nicolas Cage films and something, like whenever one was released, there was a peek in something else. So, and again, all coincidental or maybe due to some other factor, right, that was going on at the time. So yes, this is why we repeat over and over and over, correlation does not equal causation, right? This is also a big reason why we are teaching this class now, is because the news media often doesn't get this. So they'll report a correlational study as if it's causal. I mean, like, how many times have you seen a headline or heard someone say, a new study came out showing that eating 1 square of chocolate a day causes you to live longer? right? It was probably a correlation, right? It probably was not. I mean, even if it was a longitudinal study, it doesn't necessarily mean, right? And it's sometimes that's like you might live an hour longer, right? So like there are definitely things that come into play there. So it's important to keep these things in mind. All right, so your chapter talked about the half-life of facts from journals. Does anyone remember how long they said it was? Kind of a random fact, but yeah. Exactly, yep, 45 years. Woohoo! So what's that mean? Yeah, exactly. That things that are published as facts in journals and have scientific backing, right, get dated within 45 years at the maximum. So now that is obsolete. There are some things that might still be true, but we know more about them, right? So if we think about things like, the dinosaur example from the video we watched, right? So it didn't like discredit that dinosaur existed, right? Or that it might or may not have been swimming. It just gave us a lot more information. And again, partially because we develop new techniques to study these things that give us more precise information, like being able to digitally reconstruct a dinosaur from like a couple vertebrae, right? Whereas before, we would rely on artists, and sometimes they would be super accurate, but I mean, sometimes they would just sort of make their own amazing creation, which may or may not have existed at all. So I have a quick video about this idea, this half-life idea.
My name is Sam Arbisman. I'm a senior scholar at the Kauffman Foundation. I'm the author of The Half-Life of Facts. Turns out people have actually been quantifying the half-life of knowledge within medicine and other areas. I realized that maybe there's something to this. There's this larger issue of understanding how knowledge grows, how it spreads, how it becomes overturned over time, how we deal with knowledge. There is a regularity to how knowledge changes, and hopefully that's the kind of thing that can provide a certain amount of comfort to people. I think it also is really exciting that knowledge is changing, and that should be exhilarating. I think within the scholarly world, people already know at least a little bit about the idea that knowledge is being overturned. Maybe not consciously, but intuitively or subconsciously, they know that the vast majority of the papers they publish are not going to stand the test of time. This is just the way knowledge works. But then as we grow older, we might see that, oh, we read in the paper, red wine is now good for us versus bad for us, or dinosaurs look totally different from what we learned when we were younger. And that can be a little disconcerting. And so the point of the book is to say to a broader audience that, first of all, knowledge changes. That's just the way of the world. But if you can understand the order and the regularity to how knowledge changes, that can actually provide a way of structuring and ordering all the knowledge that's around you and all the facts that we're just constantly inundated with. Science is constantly in draft form. We always know that things are subject to re-examination, experimentation, and testing. Core scientific knowledge, the stuff that makes it into our textbooks, the really fundamental things, like that an atom has electrons, or that DNA is the material of genetics. These kinds of things we're pretty certain are correct, like the number of continents that are on the planet. Learn those once, you're done. Then there's all the stuff that's constantly being discovered and published on a weekly or daily basis. That's the frontier knowledge. That stuff is constantly in flux. There have been a lot of really rapid changes in knowledge since the dawn of the scientific revolution. There were some things that were big deals, like the theory of evolution. It's a pretty big deal. That rocked Victorian society. But we bounced back. There's actually an economist at Harvard University. He refers to how knowledge and new ideas become accepted, where the pace is what he calls it's crazy, crazy, crazy obvious. And I think a lot of overturning of facts is the same kind of way. You need to really look at all of knowledge in the aggregate, because the truth is we can't predict.
I'll just pause there because that's so true of new knowledge, right? Like, again, people like Galileo being branded as a heretic, people like Leonardo da Vinci seen as like crazy, right? That people are just like, this is crazy, this is crazy, this is, oh, well, duh, who doesn't like that, right?
Which specific discovery is going to occur or which fact is going to be overturned. There's only meaning in looking at all the facts together and saying, okay, if we look at all the facts within a field of medicine and then look to see how many of them are still true a number of decades later, Only then can we calculate some sort of half-life or understanding of how knowledge changes. If we're
So just real quick, what they just showed, leeches used to be used to treat a variety of physiological and mental illness. They would literally put leeches on you to suck out your blood because there was this idea about the humors in the human body and you wanted to balance them. Sometimes they would literally just touch you and bleed you into like a fancy bowl. Surprisingly enough, people who were already weakened from illness sometimes died after this. And then the other things they showed were electroshock therapy. We do still use this for very severe psychopathology. So very severe treatment-resistant depression, bipolar disorder, schizophrenia. But we use it in a completely different and much more ethical way than we used to. And then the last thing they showed was lobotomy. And lobotomy is disgusting. So it was the guy who started it literally took the ice pick from his freezer. So if you're not familiar, old freezers used to have just like blocks of ice and then you chip them off with an ice pick to get when you needed. And he would, I'm assuming, hopefully desanitize it. And then you would go in through the eye socket, up into the prefrontal cortex of the brain, and basically just sort of like jam it around. And that's what a lobotomy was. And all of a sudden they'd be like, oh, people are so much more docile. Yeah, because you destroy their prefrontal cortex, which is what takes care of personality and emotions and things like that. Aaron, did I see him? Or you just sort of like, oh, yeah, no, it's horrifying. So appropriate reactions.
taught at a young enough age that you shouldn't view your education as a done deal. You're being given the tools to think and to understand the world. We're giving you the skills to begin to continue to assimilate new knowledge and new ideas. If we can teach that, that could be really, really liberating for a lot of people. There's an order and a regularity to how knowledge changes, and understanding that can actually give you a certain amount of hope and a way of ordering the world around you.
All right. So again, a nice illustration of some of those examples of things that we used to see as fact. I have a couple other examples of those that I was going to go over, but I want to make sure we get to some of these other things. So if you want to go back later, these are some of the examples mentioned in your book. So the Kitty Genovese case is supposed to be used as a study for years, or example for years of apathy among people. Like the idea was, oh, they people just let her get murdered and no one did anything. But in fact, like when they went back and like interviewed witnesses, several people tried to do things. And then the idea of oxytocin being the love hormone, it's much more complex than that. Essentially, it does seem to be most linked to bonding and trust. And they thought it was like only like romantic love or like moms and babies. But in fact, now they're showing that it might be linked to friendship too. But again, if we think about things in the brain as like those are just facts, right? And this is showing like our knowledge of the brain has to adapt and change over time as well. All right, so I had some fun taking some facts, right? And then taking the questions from your book about how we should assess different facts. So the questions we'll walk through for each one here. And the first one is, you know, COVID is a hoax, and your source would be a person on the internet. So the first question you would ask is the belief based on unsubstantiated claims? What do y'all think? Yeah, right? No, like Dr. Fauci did not spend 50 years doing virology just to be like, gotcha, right? Does it rely on unwarranted assumptions? That kind of goes along with it. Does it make sense? I mean, to these people in their sort of strange, convoluted way, it does. But to just like a rational person stepping backward, you're like, why? Why would we go through this elaborate hoax? Where did the data come from? I don't know, QAnon? Like, they're like these dark corners of the internet. There's a really good docuseries about QAnon on HBO Max, by the way, that I watched during the pandemic, and it's very telling. And is there an agenda? If there is data, yes, right? And will the results survive the trip from the lab to the outside world? Well, there's no lab, right? So, And is there another way to explain the results? Well, yes, there's a virus that's killing millions of people worldwide. We didn't make it up. All right, here's another one. And this is, again, no shade at anyone who does use acupuncture, but this is something we commonly hear. It's an ancient practice that eliminates a host of issues. So what do we think? Is this based on substantiated or unsubstantiated claims? What do people think? Okay. Yeah. I mean, there's not a lot of data on this. This is something we talked about in passing before too. The fact that it's like ancient, it sort of like mystifies it, right? And it's often sort of like racially charged in a not good way, right? So like, oh, the ancient Chinese, right? These like stereotypes about mysticism, and yeah. Does the finding or claim make sense? Potentially, right? If you kind of look at a theory, the way that they set it up of the meridian lines in the body, sure. But when we map that onto modern science about neurons and the circulatory system, it unfortunately doesn't map onto anything physiological, right? You could argue that there's a spiritual component to it, and that's entirely possible, right? But not something we can test. And so one of the things that we've discovered with acupuncture is it does make some people feel better, even though it's not actually going into the biology of things. So what would be people's guess why that's happening? Yeah, Aaron. Exactly, yeah. One of my favorite headlines I've ever seen about acupuncture is an elaborate placebo, basically. And you know what? There are times we use placebos for people to, help them feel better. So if it does help people feel better, great, except, right, when people are being asked to spend a lot of money on it, right, when they could maybe use something cheaper that'd be more effective.
Is it true when they say like we can control like their own like I don't know how to say it, but like basically the placement and stuff, like if you take it and you like, okay, it's gonna work, is it like
Oh, that's a good question. Is it sort of like the putting it out into the universe type thing? So this is sort of complicated. So the idea of like the secret doesn't have like if you just put it out in the universe, you'll go to Fiji or whatever, right? But there is a lot of science about the power of positive thinking, right? So if you do believe you can do something, you're much more likely to try it and do it well. And we also know that if you set goals for yourself, right, you're much more likely to work hard to achieve them. So I think there is some backing in that way, but not in the mystical, like you just put it out there and you don't have to do it, right? So yeah, again, things that are cool ideas and no harm to anyone unless, like the maker of the secret is charging you $300 for like this package to make it work, right? Like, I don't know if that's true for that, but that is true for some of those like cultish things, right? We won't even talk about Scientology. There's a video about this that I'll skip.
It doesn't.
And this is actually a neurologist talking about, he basically just says it doesn't matter where you put the needles. So, all right, here is the one I referenced the other day. So this is a belief we have. Standing 6 feet apart will protect you from COVID. What are the possible reasons this could now be a myth? Yeah. Exactly. So aerosols are really small particles that essentially travel on our breath, right? So think of like if you have like an aerosol of like sanitizer or hairspray, right? How far it goes. And let me click to the next slide because this is actually fairly complicated. I put a link to this article in the PowerPoint, but then also on Blackboard if you want to read it. This Wired article is really good. It is basically scientists who recognized this was an aerosol had to fight to get even the CDC to acknowledge that, because there was this 60-year-old, not really typo, but just sort of like misinterpretation of some data that was codified into documents at the CDC. and just replicated over and over and over, where they thought aerosols had to be a certain size and COVID was like larger than that. But in fact, when you look at the data that's happened since then, or even if you go back and reanalyze that original data, it says COVID could be an aerosol. And so this is why this fact, unfortunately, still exists, right? Like Wesleyan has told us, hey, you can wear masks outside if you stand 6 feet apart, or you can not wear masks outside if you stand 6 feet apart. Okay, right? So I have a quick video about this one here.
Subscribe to our YouTube channel and press the bell icon to get the latest updates.
In a new set of COVID guidelines, the government has highlighted the importance of well-ventilated spaces and stated that aerosol and droplet transmission are a risk. According to a document released by Principal Scientific Advisor K. Vijay Raghavan's office, while droplets fall within 2 meters from an infected person, smaller aerosol particles are carried in the air up to 10 meters. On today,
If you're not familiar, 10 meters is about 40-ish feet, right? So much more than 6 feet.
Down to the print, we talk about aerosols. An aerosol is a suspension of extremely small liquid droplets or solid particles in the air. The aerosol material exists in the liquid or solid state and is carried by the air into the respiratory tract. Aerosols are generated from an individual when speaking, singing, coughing, or even just breathing, and can carry the virus if the person is infected. Droplets are 5 to 10 micrometers wide, while aerosols are less than 5 micrometers. The virus is just 0.1 micrometer wide. Both droplets and aerosols have the ability to carry.
So that data she just cited is the revised one, based on the redoing the data. They used to think it had to be even smaller than COVID is.
Carry viral loads, but aerosols can travel further, transmitting the virus over longer distances. For the print, this is Pia Krishankuti. For more, visit the printout.
So yeah, again, we have to revise our guidelines based on things like this. The other thing we should probably revise our guidelines based on is things like knowledge from social science, right? So when they said in June, everyone who's vaccinated can go around without a mask, honor system, like any psychologist or sociologist could have told you, well, you just shot yourself in the foot, right? Like, because no one's going to go by the honor system, right? People are just going to be like, cool, I don't have to wear a mask anymore. And so, like, yes, the biological and the medicine science could be correct about that, and was, right? They wouldn't have just said that. But the social science could have told you need to look more at human behavior, right?
Subscribe to our
So like there's part of me that's just like, oh, CDC, hire some social scientists. I know they have them, but listen to them, I guess. Here's some important terms from your book. The availability heuristic is essentially, this is a fancy way, this definition of saying you make your decisions based on the information available to you. So again, the people who are saying COVID is a hoax, the virus is going to microchip you, they're only seeing that in their bubble of what they're looking at, right? And so they are making decisions based on that information. Your book also talked about effect sizes. So this is a way to essentially compare the strength of the relationship between variables across studies. So whether it's a correlational study, we just looked at that there's an association, or whether you've done an experiment and you could say this causes this. This allows you to look across any type of study, any sample size, any methodology, and say, how do these compare? And meta-analyses, where you synthesize a lot of this data, rely on effect sizes, use effect sizes to look across studies, calculate sort of like average effect sizes, things along those lines. Statistical significance is what we think of when we think of significance in the psych world. So it shows that there is some sort of relationship between the variables, and it is essentially, usually we use like P is less than 0.05. That means that there's less than a 5% chance this happened by accident. However, sometimes statistical significance doesn't really have a real world impact. Right, so let's say you find statistical significance between two groups on a measure of depression. But like, let's say the cutoff to measure for depression is 30, and you have one group that's scoring a 35 and the other group is scoring a 34, right? So like, yes, if you have a big enough sample size, that might be a statistically significant difference, but does it make a difference in those people's lives? No, they're both above the threshold, right, still. So clinical significance is something we really want to take into account in this class, but also in any sort of applied psychology setting that you might end up in. So this is Cohen's old rule of thumb for essentially what is a small, medium, and large effect size. Often the one that we use is Cohen's D. This is what you see in a lot of reporting. But probably the easiest way to interpret it, if you are familiar at all with some stats, is R, or the correlation coefficient. So R, the weakest one is 0, and the strongest R is 1 or -1. And the sign just tells you the direction of the correlation. So you can see, if you're at a 0.1, that's considered small. Even if you get up to a 0.5, that's considered large, because sometimes we just don't find that strong of relationships between things. So you get a nice indication. And again, you can compare these rubrics, these metrics, and there's really cool software now that allows you to like synthesize data from a lot of different types of studies to do this. This I loved. I found this on Twitter, maybe 3 days ago, probably when this guy tweeted it. And it really, I thought, was a nice description of what we're trying to get you to think about in this class. So a balanced argument doesn't weigh two sides equally. It weighs the strongest evidence more heavily. Critical thinking isn't about representing every view. It's about recognizing your biases and giving serious consideration to facts that contradict your hopes and beliefs. So I really liked this because I think that we see this in the media, we see it in ourselves, honestly, right? Like, oh, I need to give the other side equal time and balance things out. But in fact, that's not what critical thinking means, right? It's acknowledging there's another side that exists, but then saying, where does the evidence lie? Just like those few examples we just walked through. Alrighty, the next thing I had on here was just about how to read a journal article, which your article about it walks through. My biggest suggestion when you read a journal article, which this gets at as well, is read the abstract first. That's a good summary of what's in them. And then read the introduction and discussion. The introduction will give you the context and the background for the study. The discussion will tell you what they found. So the discussion basically takes all those numbers in the results section and puts them into words. So, but this gives you really nice guidelines on how to read a journal article. Alrighty, we will stop there for today. On Monday, we'll start with a group activity related to some of this. And everyone have a good weekend. We do have class Monday, even though it's Labor Day. All right, y'all have a good weekend too.